Okay, for this question, I'm going to lay a claim and we'll try to go around and investigate this claim. So I'm going to lay a claim that the only numbers that have odd number of positive integer divisors are perfect squares. And what perfect squares are powers of 2. Just for the vocabulary. So I'm going to say that's only perfect squares. And we'll figure out why. So when you have a number, you always can split it into a factor. Oops. You always can split it into a factor and another factor. And what I mean by this, let me explain, is so let's say I'm going to go with 60 as an example. So 60, for example, has factors 1, 2, 3, 4, 5, 6. But then from here, if 1 is a factor, then 60 over 1 is also a factor. 60 over 2 is also a factor. 60 over 3 is also a factor. 60 over 4 is also a factor, right? 60 over 5 and 60 over 6, right? So what I intend to say is all factors come in pairs. All factors are divisors. These are kind of interchangeable names. So they come in pairs. But when it comes to perfect squares, you have a bunch of factors, for example. So I'm going to say like 49, for example. You have 1, 7, 49. Well, 7 pairs with itself, right? Because 7 times 7 is equal to 49. So, but you, in terms of divisors, you only write it once. So that's why perfect squares have an odd number of integer divisors. Because the number k, if a perfect square is k squared, the number k pairs with itself. So using this idea, all this question is asking is the number of perfect squares below 50. And again, positive integers, so you don't count 0. So it's 1, 4, 9, 16, 25, 36, and 49. So that's 7 of them. So that's our answer. So here, the key was to notice that perfect squares are the ones, the question is equivalent to asking how many perfect squares are less than 50. And what we learned out of this is that factors pair with each other. And so if you are trying to list a bunch of factors, you can, the way I go about it is if I say, okay, 1, 2, for example, for 60, going back to 60, 4, 5, 6, the next factor, for example, so 8 doesn't work. 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 works, but then 6 times 10 is equal to 60. So then it's just going upwards from there. So then I just write all the pairs out with each other. And it makes life much easier because you don't have to think too much when writing out the factors. Okay, next question. So for a positive integer n, the factorial notation n factorial, we learned this when we were doing counting, represents the product of integers from n to 1 or 1 to n, right? For example, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is 720. What is the value, what value of n satisfies the following equation? So I'll give you some time to think about it and then we can work it out together.